Yeah, I know you're gonna record.
I'm gonna record it right now. I just started. And I'm gonna record at 1 o'clock, man. I'm so focused today. Not that it'll work, it probably won't work, but it is recording now. All right, so week 5, I did some grading. Look at your grades. If you have a 0, reach out to me. Well, if you have a 0, whatever you're missing, upload it first. Like, just get that done. And then I'll grade it probably. I'll probably give you full credit, but not past week 5. Now that we kind of know the system, if Marco blows it, you got to keep track of him, man. He's just a kid.
I know, but.
All right. Calendar, the quiz never came up. Nobody told me that, but that's all right. I hadn't given you good feedback, so I wasn't really that heartbroken about it. I don't want to, but you should want quizzes. Like, they're easy points normally. Anyway, this one is already up. So it will definitely come up. And it's due Friday. So you can look at it. It's in the folder. You'll figure it out. Today's little exercise will probably help you, but yeah, sorry about that. But that's all right. Nobody was heartbroken, I could tell. Let's go over a few things that you should get feedback on before our quiz, or definitely before an exam, or before we move on, because we don't want to continue to do things wrong or incorrectly. So first of all, look through the grading, look for my comments. If you see a loss of points for some reason, then look at the comment. If you can see you got full points, I probably just said nice job, right? There'll be an extra credit or 2 before the end of the term. Yeah. All right. So unless otherwise told, we're going to keep our, oh, you can't see it. We're going to keep our dimension unidirectional. In other words, don't be flipping it around. Okay. All of it's horizontal dimensioning. Unless you're told differently. Architectural or the construction world does flip their dimensions at times, but it's really not common anymore, not even in civil engineering. We're going to keep all of our dimensions one direction. So this is a horizontal dimension, right? Horizontal text. If we had a vertical dimension, we would still have horizontal text. Okay? Just keep it horizontal. The other thing is our arrows touch the extension lines. So they point to whatever you're sizing. So they don't point anywhere else. They point to whatever you're sizing. If your text doesn't fit, then your arrows can go on the outside. So you can put them on the outside, but they still are going to touch that extension line. And that extension line is going to go to whatever it is you're dimensioning, right? So keep your arrows touching your extension lines, and you can move them outside if you need to. Like, if this didn't fit, this fits easy, but you could run with your arrows outside. That's more preferable than actually, trying to squeeze it in. Well, that's all right. And then this text could be in here. Maybe there's 3 lines of text for some reason, a big note on that dimension, right? Then you had to just pop your arrows outside. Perfectly fine. All right. Exactly what Devin and I were just talking about. We prefer our arrows to go to extension lines. Okay. But if you got to put it to the object, put it to the object. Like, if it's just more clear in here somewhere and there is no extension line, that's fine. It's still off of the object, right? It's still off the object. It's just not using an extension line. It's using the object. It's okay. You can do that. We prefer it to be 2 extension lines. All right, what else? Oh, leaders. Let's talk about leaders. If we have circles, most of your leaders are fine. They're super handy, like you can sneak them in places and then you can put a bunch of text on a leader, right? So when you're putting leaders on, this is in AutoCAD too, although AutoCAD's automatic with it. It's gonna do this automatically. The leader is supposed to extend through the center of the object, whatever it's marking. So this would be a good spot for a leader. Like that doesn't break any rules. Right? Because if it kept going, it would go through the center. That is breaking the rule. If it keeps going, does it go through the center? No, it doesn't. So that doesn't work. Try not to do that. So, and we use leaders for all kinds of things. You can call out radiuses like this, if this had a radius. Right? If we're going to call that little radius out, you have to think about, oh, here's the center mark. Then I want to, if it kept going, and I don't like that, I'm going to put it down lower. If it kept going, it would go through the center, same kind of rule. But use them, like they're super handy. You can sneak them in all kinds of places. We don't want to cross dimension lines. So dimension lines hold the text, they hold the dimension. That's why we call them dimension lines. These are extension lines. So we just don't want to cross these. We want these to be clean. View names go underneath the view, under the view. You got to plan for that when you're doing manual drawing. Put them under. The proper positioning is front. I think most of us have this down, right side, and then top being above the front, right side being to the right of the front. Front sets everything up. Okay, if you know you're going to do front, top, and left side, because that left side might be more descriptive than the right side, and you got to kind of shift everything over, right? And get front, top, and then left would go over here. Same with bottom, like for some reason you want to draw a bottom view, it'd have to go down below the front. Everything needs to stay in that kind of perspective. Everything's in projection. I don't remember. Huh?
Doesn't matter if you do like front view versus front. Can you just say front or do you need to say?
You can just say front. Yeah. Yeah. I often just go front, right, top, left, bottom, auxiliary.
We don't have that. I mean, I guess because most of the engineers, they're already lazy and
Yeah.
they don't write anything on it. I mean, as a machine, you already know that it's the
Yep.
front, the right, and
Yep.
at the top.
This reminds me of ski patrol, like, right? We go through this medical training and this is exactly how you do it, but then you get on the mountain and you're like, you're just gonna like hack it together however you can, right? Same way, I'm gonna try and teach you the standards.
Yeah.
And then when you get out there, you'll see. I mean, you'll see this kind of stuff, just a nightmare of dimensioning, like nobody even thought about clarity or what it, or who's gonna, the poor sucker that's gonna read it, right? Yeah, it's a problem.
You said that you want to go work. There are some friends that I have been 25 foot taking over a lot of sections.
Oh yeah, lots. Okay, I think that's pretty much it. Any questions about anything? We're gonna leave graphics behind after today. We're not gonna do any more instrument drawing, so you get a break from that. But we are gonna play with sketching a little bit. Because sketching is fairly important. And it's one of the standards that's supposed to be covered, so there you go. It's kind of a lost art. Like when you sit down with engineers and really have a conversation about a project, you might have drawings in front of you, but there's something else that somebody's trying to describe and nobody's getting it. And finally someone tries to draw a sketch and it's like, whoa, nobody does that anymore. So we're gonna do it a little bit.
We do that a lot. We have a lot of whiteboards.
Sometimes you'll go into a room after a meeting, you'll see a bunch of sketching and it's like, wow, that's really bad, you know, that kind of thing. But whiteboard sketching is a whole different gig.
Yeah.
Yeah, than paper. Yeah, I mean, it really is. Like same with chalkboard sketching. It's this is better for sure. But I just want to give you some techniques so you have at least a fighting chance at it. It's not art. Well, it is kind of art, right? And I do a fair bit of it on new projects that I do because I'm conveying something to a customer. And the customers, I mean, I can explain all I want to about the layout of something, but if I can just sketch it and give them a three-dimensional sketch of what I'm thinking, they'll be like, I like that, or no, that's not what I was saying, right? And you can move on quickly. Where you don't have to have an iPad or a laptop or a software in front of you to do it. Like you can just sketch it up real quick. So we're gonna do that just a little bit. And I'm gonna give you some basic techniques. All right, so we went through the whole front top side thing. So with basic hand sketching, really what we want to think about is parallelism. We want things parallel that are supposed to be parallel, right? So when you're sketching lines, this top part just talks about in order for things to be parallel, they got to be kind of straight. And in order to get things straight, you're going to need a starting point and an end point to your sketched line. So you just have to think about like, where am I sketching this thing to, right? So really, we're just focused on straight lines. Like that's as artistic as we're going to get in the beginning, right? So you're going to want to have a starting point and then have an ending point, and you're going to want to kind of work your way towards it. You don't want to just stick the pencil down and try and draw one line. It's just not effective, right? You want to like draw these small strokes. So if I was going to do that here, grid paper is super nice. That's another reason why I'm armed with it all the time in case I have to sketch, right? So you just want two spots, a start and an end point, and then you want to work your way to it. And what I do is I work my way to it. Oh, here, let's do this. It'll focus on that. Maybe. All right. So here's my start. Here's my end, right? And I'm going to work my way to it. And then I stop, especially if it's at an angle, and I start working it from the other direction. And then I bring them together. So that's one technique. Focus, good. So then if I was going here to here, on an angle is much more difficult, right? So I'm aiming at that. Now I'm aiming at that. And I can kind of get, and if you keep it nice and small strokes, you'll start to get a line, and then you can just like start to work it in. Start and end point makes a big difference. Okay. And then obviously parallelism. So if I was going to go, and this is a top surface of some kind, right? So maybe this comes out to here. And then this is going to come out to here. I mean, sketching is all about like, I don't want to put a ruler down. I just want to sketch this thing up. So I have to think about like, oh, this needs to stay parallel to that. So even though it's quite a ways apart, I can get a feel for it if I just think about keeping it parallel. So I was probably more focused on this line when I sketched this one than I was about this line itself. So I was constantly checking, even though it's far apart, you can still kind of get it parallel if you focus on that, right? And then this one would need to be parallel to this one. And I can feel it moving away. I'm not focused on that point. I'm just focused on trying to stay parallel. I think it's slightly off, but it's good enough, right? Good enough. So that's the other big thing is start and end point and then keeping things parallel. All right. So again, that's just, you know, when you're sketching, it's okay that these overrun for sure. And just think about parallelism and these smaller strokes. It's going to really help. Round objects, super hard to sketch round objects. Okay. So box them in. Box them in means, like, if I'm gonna draw a round object and I know how big it is, it's like this big, and really lightly I box it in. I think about where the quadrants are. And then I just think about these fillets or quarter rounds, right? And you really want to pull them out, like that's supposed to start pretty tangent to that spot and pretty tangent to that spot. That'll keep things round. And then you just want to pull it out and try and round each corner. Hard to do. Like this should have started out. Keep it nice and light, and then you can darken it in later. So no matter where that is in your drawing, box it in. And if you box it in real light, you can just leave it there. That's fine. Gives it a real engineerish flavor to your sketch, actually, which is a good thing. If the hole is on a three-dimensional object, then it needs to be in the correct axis, or it's going to look really weird. Like if there was a hole in this surface, assuming this is some kind of a staying better focused now, isn't it? Some kind of a three-dimensional object, right? I just drew those. I just thought about keeping them vertical. Vertical. All right, so maybe there's a hole in here. Box it in. And that'll tell you where the long axis is of the ellipse, because it's going to be an ellipse on a three-dimensional surface, right? That'll tell you where the long axis is and the short axis. Remember, an ellipse is, it's got a long axis and a short axis. So it does something like this, right? Kind of long and squishy, but where is it? What's its position? Box it in, and that'll tell you. Then you can do your quadrants again. Then these are very flat out here, and these get pulled way out. That will always put your hole in the right angular position. Okay? If that hole was here on this surface, it doesn't look like that. That's this top surface, right? So again, box it in. Boxing it in just means, hey, keep everything parallel, parallel, parallel. And then pull it out from the quadrants. When I was designing my own home, which I did, and I made like these beautiful drawings, which is a floor plan, right? Or an elevation. It's the flat views. My wife's like, what the hell is it going to look like? Right? Because she's looking at the floor plan going, I don't know what that's going to look like. I'm like, oh my God. And she's right. Like, people can't put that together in their head, right? She's like, what's the kitchen look like? So I just spent hours making these three-dimensional sketches of what that space would look like. Oh, it sold the project, right? To my wife. I was trying to sell this project. And I'll bring them in. I kept them all. Like we've made a book out of them. Because after I kind of got into it, I really got into it. And I started making sketches of like closets. She's like, I don't need to see the closet. I'm like, well, still, it's cool.
So you're talking about the house, your house that you.
The house that I currently live in that doesn't have a coat closet. Yeah, yes. I should have sketched that. I should have sketched the entry, because to this day, she complains about the entry. Because when you walk in the front door, the steps to the loft literally are right there. Like, that's just, architect would never do that. There'd be more space there. But I didn't want the house 54 feet long. I wanted the house 50 feet long. Like, that's big enough. Anyway, you don't need to hear all those troubles. Okay. I'm going to bring them in. Yeah. They're super fun. I look back over them and go, man, how many hours did I spend on that? Especially the living room, because the living room has, like, where's the TV, where's the couch, that concept. And we have it's like living in a fishbowl. There's windows everywhere. So it's like, where do you put the TV if you have windows everywhere? Like, there's nowhere to put it. And then there's this giant bookshelf that she wanted in. I'm like, oh, how are we going to do that? Yeah, I spent a lot of time sketching that stuff. It was super fun. All right, good. That'll help. Box it in, it really will. You won't end up with stuff in the wrong position. If it gets real big, you can kind of slide these radiuses in. And that'll help you circle it up. So the other thing with sketching is we don't typically do it to a scale. So my sketches aren't to scale, they're to proportions. So if something is twice as tall as it is wide, that's your focus. Like, oh, twice as tall as it is wide, I can do that, right? I don't need a scale to do that. If it's 3 times to 1, then that's the proportion you think about. Here they're using their pencil to kind of figure out the proportions. But just think about that. Box it in, talked about that. Let's talk about the basic 3-dimensional sketches. This is called an isometric. So this is, if you go to your next party and ask somebody, hey, what's an isometric sketch? They'll be like, oh, I don't know, man. But if you ask them to do a 3D sketch, they'll give you something like this often. So an isometric sketch has what's called the isometric axis. That's this thing. Okay. And it's about 30 degrees. If you change this 30 degrees, like if you make it steeper up to 40, you'll see more of the top. If you take it down to 10, you'll see less of the top. The flatter you get, the less you see at the top. So you can change it. Like if there's more geometry in the top that you want to show, then steepen it up a little bit and you'll see more at the top. If you kind of want equal sides, 30 degrees is the approximation. Okay, and you'll see this be repeated. Like here it is right here, right? The isometric axis. Here it is here. Right, it's there, it's here, it's down here, here's part of it. It all kind of repeats to give you this 3-dimensional isometric feel. Super common. Of course, you can do it in different positions to get different shapes. The other one, less common, but you see it a lot, people don't even know they're drawing it, is this top one. And this is called oblique. And essentially, you use the real front view. You literally draw the front view, right? Just the way we've been doing it, the flat front view. And then you just shoot off some 30-degree lines and you have depth. This is the easiest 3-dimensional one to draw. It's less realistic. But people don't know it. When you show it to them, they're like, oh, I get it. That's a 3-dimensional object, right? Well, it's really just the flat front. And then you shoot off some lines and you have your 3-dimensional object. So it's pretty easy to produce it. You just pick the most descriptive view and go for it. Okay. And then there's a perspective. This is a perspective. This is the most realistic view. Kind of the biggest pain to draw though, because you have to have this vanishing point thing. But again, you just draw the flat front, pick a spot kind of up and to the right if you want it to be that way, right? So you pick that vanishing point and then you use a straight edge and you literally draw all these lines, go to that vanishing point, and they give you perspective of the object. Right, now we're getting a little artistic. This doesn't take a lot of skill. You just got to set it up right? And then you can have a 2-point perspective, meaning you have 2 vanishing points. So if there was another vanishing point over here, then you'd send some lines there, and it gives it this real 3-dimensional feel. Yeah.
Any rule on the vanishing point for degrees of view?
There is, and I have forgotten them. It's not a 45, so it's not equal. It's like, from what I remember, it was like 6 units over 3 units up type of thing. Yeah, kind of back to that 30-degree thing. Yeah. But if you just put a vanishing point really high, you'll see how it all just kind of goes up, or really low, it'll be really flat looking. And they say that's the most realistic. Like if you look at railroad tracks, they come together in the distance, right? That's vanishing point. That's what our eye sees. So those are kind of fun, not too complicated to do. The key, like the key to this is keeping things parallel. Like you'll get a good box if you keep things parallel. As soon as you do that, then your head starts to go, what is that? Like, I'm not sure what that is. I mean, that could be an object, right? If that bottom part was sloped, that's what it is. But if it wasn't supposed to be that way, then it really messes with your head. Just if this was like this, then it just starts to, your head puts together nicely. Okay. All right. So here's the tricky thing that we're going to do today. You're going to do this. You're going to create some three-dimensional sketches. The first one is just going to be a copy, essentially. You're going to create a not complete copy, because what kind of sketches are these? Isometric. They work off the full isometric axis, right? And I've asked you to create a oblique. So it's not exactly like this, is it? What do? We take the front view and we just shoot the angles off to create our oblique. Okay, and I think you're doing number 4, that one, which is gonna be a little tricky because it's got an angle in it. It's got an angled surface, so you have to kind of figure that out. Okay, so that's just one sketch. Green paper is fine, white paper, whatever you want to use. Then you're going to do another one. This one is starting to play with the puzzle of, from a 2-dimensional sketch, make me the 3-dimensional object. It's tricky. These are simple and it's tricky. Okay, now these also have missing lines in a view, not in multiple views, in a view. So here's one, right? This is the front view, right side view, top view. Where do you think there's a missing line? So somebody said the right side view is missing something, right? What's it missing? This thing, potentially we could see it because here it is here, right? Yeah, so that made that. So there's a notch out, and that, shouldn't that be like, here's the right side view, shouldn't it be showing up here? Yeah, so finish the views first. What if any other missing ones? I see another one. The top view for what geometry? The pointy part. If there's an edge, it should be represented up here, right? So this has multiple lines are missing. So fix that first. And then you got to try and draw, what did I ask for? An isometric sketch of the object. Okay. So one idea is to just, I'll just give you some hints on this. This is the front view, correct? Yeah. And then this would be the top view. And this is the right side view. So if I was going to do that one, you could, this is one strategy. I know we can't see it now. Oh, actually we could see it if I left this small, right? And slid it around, kind of. Yeah, we can kind of see it. Not very well. Focus. Yeah, so if we're doing this one, just as practice, one of the things you could do is set up a, and I asked for isometric, right? Yep. So I'm going to set up an isometric box, and I'm not spending much time thinking about proportions, but it looks like it's longer than it is tall. Yeah, it's pretty tall. Yeah, okay, I'm going to say it's rectangular in the front view, right? And then the side view, it's kind of pretty skinny. So all I did is I set up a cube that's going to hold my object. Does that make sense? And then I go back and I say, okay, the front view looks like this is shifted over, the point's up here somewhere, and it comes to about here. I can start to sketch in the front view on the front surface. Does that make sense? And then maybe this comes all the way down to a point. Now, the only thing wrong with this, it could be at a depth. I'm assuming it's on that front plane, right? But this really, this could be back here somewhere. I don't know that for sure, right? But it starts to give me a feel for the object. Now, if I look at the top view, it looks like maybe this point goes all the way across. So I'm gonna send it all the way across.
That would depend also on the side view, right?
It would, but the side view looks like it's all the way across, so it
Yeah.
might be that edge right there.
Yep.
Yep, okay. So then I'm like, oh, maybe this thing does this, right? Comes down, and then from the top view, I see there's like this notch out thing. So it's a little guessy when you're doing it, but pretty soon you start to like see an object show up. The next thing you want to do, once you think you're getting somewhere, is you want to get stuff out of there. So do this really light. And then go, okay, I think this is gone.
Layout, right?
Huh?
Layout.
Yeah, absolutely. What else should I take out of here?
Upper left portion.
Maybe this corner?
Yep.
Yep. And maybe this thing. Because I think it's a knot. According to the top view, this is just clean, right? And then maybe since this is parallel, maybe I can barely see that. And then this stays parallel to this, right? So it's starting to take shape.
Same thing on the bottom, right there.
Yeah? And that stays parallel to that, and to this, and to this. All right, it's coming together. I think I got it. So the way to know that you have it is then to create the three views from this without looking at this. Because if you can do that, then it works. If you can't, then something's still wonky. This is just helping our brain going from 2D to 3D, back 3D back to 2D. Just practice. Good? All right, you're gonna do number 1. It's easy peasy, man. Easy peasy. Don't muck it up. Questions?
So guys, we're just gonna sketch it back out and then put it back to what that is.
Yeah, you don't have to go back to that part, but I would do it to check it. Like if you can, in your head or just on a scratch piece of paper. Yeah, prove that it works, exactly. Yep. It's hard to do because you made the object and you convince yourself that was right, but if you step away and then come back and go, oh, that top view doesn't match, then something's wrong. Yeah. All right, you're doing number 1. That's it. Two projects, this one and this one. I can print them too. What is that? 13 or 14 print.
The transfer, the other one.
The what? The quiz?
Quiz, yeah.
It's in the folder. 13.
Online. I can't access it at all.
What's it saying?
There's just nothing.